Hello everyone, my name is Ankush Jain and in this video I will be talking about AWS AppSync. AWS AppSync is a managed AWS service to build GraphQL APIs. Now when I say managed, that means you don't have to create any server to deploy or host your API because the servers where your API is being hosted is managed by AWS. So you just need to go in AWS console, create an API, you will get an endpoint and you can start consuming the APIs. So you don't have to worry about the servers. And that's why we can also call it serverless API. All right. So now in this video, you will also learn the fundamentals of GraphQL as well as fundamentals of AWS AppSync. So we will start everything from zero and then we will gradually move towards advanced concepts. So don't worry if you don't know what is GraphQL and what is AWS AppSync. You will learn everything in this video. You will learn fundamentals as well as advanced concepts. Additionally, I will also show you how to build GraphQL API with practical demonstration. So you will actually learn how to build GraphQL APIs rather than just theoretical learning. All right, and okay, so now let me take you to the this section. What you will learn. So here I have added the points that I'm going to cover in this video, and you can directly jump to the part if you are already aware about any specific topic. So first we will cover the differences between API gateway and AppSync. So what would be the difference if I create an API which is deployed on API gateway as compared to AppSync? Then we will see a typical architecture of a full stack application. Then I will explain you the fundamentals of GraphQL. Then we will learn quickly the fundamentals of AppSync. And then we will have two hands-on lab where I will show you how to build GraphQL APIs with AppSync. So initially I will show you how to do it via AWS console. Then that is the manual way. Another is the automated way, which is more advanced. That is optional. If you want to learn, then you can check out that section where I will show you how to create APIs with AWS CDK. And then finally the API has been created. Lastly we will learn how we can consume or integrate that API in our Angular application, and there I will also give you a brief about AWS Amplify library. Okay, so that makes quite easy to consume GraphQL or AppSync based APIs in your front end application. It's just Angular application, but you can you can use a similar logic to consume it next inject Next.js, React.js, Flutter, or any other client application. All right. So moving to our first point, the difference between API Gateway and AWS AppSync. So just scroll down and yeah, here it is. So first of all, I would like to tell you this is the page that I am going to refer in this video. So you can find the link of this page in the description below. All right. So now what would be the difference if you create an API with API Gateway or AWS AppSync? So here's a typical architecture that I have created. Or so you can see this is the user and here this is the Next.js application. And let's first talk about API Gateway. So first of all, API Gateway is basically for REST APIs. So whenever we want to build REST APIs, then we will go with the API Gateway. But when our choice is to build GraphQL APIs, then we will go with the AWS AppSync. Now, if you see typical architecture of REST API with which we create with API Gateway, so that looks like this. So we have an API Gateway and we have bunch of Lambda functions, and those Lambda functions has the code to interact with DynamoDB. So the user will basically access the application front-end application that might be hosted on AWS Amplify hosting or on S3 or any other platform, and that application will interact with API gateway. Now when the first request will arrive, it may take, because the Lambda function has a cold start issue, that might take some time to start, and then it will, once it is started, it will send the request to DynamoDB. So this is how a typical API works. And what happens in this case, you have different endpoints like create, read, update, delete. So you have different endpoints, like you will have a base API gateway URL, but you have um, um, different last segment. Like you have for create, you will have slash create. For update, you will have slash update. That kind of segments you will have in your API URL. So now talking about the AWS AppSync, which is just like this. So if you want to interact with DynamoDB, you don't have to create any Lambda function in between. You can just write the resolvers here in AppSync. I will show you how to write them, and you will just consume the API with GraphQL endpoint, and that endpoint will basically directly communicate with the DynamoDB. So there is no Lambda function in between. Hence, you will not face cold start issues in your application. And second thing, you will also not have to maintain different routes, like for different endpoints. GraphQL API is just has one endpoint, and you can access all the operations within GraphQL, uh, in GraphQL API with that one endpoint. So this is a high level difference between these two services, API gateway, AppSync. I am not saying that I have covered all the differences, but there are a lot of other differences. API gateway also offers a lot of other functionality which AppSync doesn't, and similarly vice versa. But yeah, I mean, just remember, if you want to create a REST API, then go with API gateway. If your choice is GraphQL API, then go with the AWS AppSync. Moving to the next topic, the typical architecture of a full stack application. That I mean, if you this is the architecture of an application which is basically consuming GraphQL API. So because this video is all about AWS AppSync and GraphQL API, that's why once you learn how you have learned how to build GraphQL APIs and deploy it via AWS AppSync, then this architecture will be your next step. So what will happen? What will you do? You will create a front end application, and again, this example shows Angular, but it could be any application. Then you will store it via GitHub. The code will be stored either on GitHub or AWS Code Commit or any other Git repository. Now, what happens when you will push the changes in or push new changes in these Git repository? I'm assuming that you will be hosting the application on AWS Amplify. So AWS Amplify will build your application and will produce a new version of your application, kind of new artifacts, and those artifacts will be automatically deployed on Amplify hosting. Now a user or your applications user will be consuming the front end application from your mobile or browser, and this application will be basically communicating with the AppSync API, and AppSync API may have multiple data sources. So it is not like your AppSync API can just communicate with DynamoDB. It can also invoke Lambda function. It can also invoke other data sources as well that we will see in later in this video. Now, once this communication is happening properly, we will also ensure the security should be in place. So we will also add Amazon Cognito, and we will secure this API gateway, sorry, AWS AppSync API with Amazon Cognito, also the front end application with Amazon Cognito. And by the end of this video, you will see, I mean, this part kind of in action, like front end application will be there, AppSync API will be there, Amazon Cognito will be there, and Amazon DynamoDB will be there. All right, so just be with me till the end of this video. And if you have liked the content so far, so you can press the like button or subscribe my channel for more AWS related content. All right, so we have seen the typical architecture of the full stack application. Moving forward, the GraphQL fundamentals, right? And this is the part where if you are not aware about GraphQL, don't worry. When I first started, I was not even know what is GraphQL and whether it is being used to create APIs. But these are the fundamentals are very important, and trust me, they are, it is very simple, and it is, GraphQL just looks difficult if you have not if you don't know these fundamentals. Once you know these fundamentals, everything is good. So first thing you need to know, anytime you need to create Okay, first thing, GraphQL is a language and that you can use to build APIs, right? GraphQL is used for API development. Now, whenever you are creating an API, you first have to create a schema file. That is a kind of prerequisite if you want to create a GraphQL based API. So you have to learn how to create a GraphQL schema because that is the primary thing that you have to do. So I am taking an example of a to-do manager application. I don't want to keep things complex. So just starting with a to-do manager application. And if you have to create a to-do manager application, what kind of interface you will create? So uh, look, so you have to kind of have, I mean, I'm talking about here, think of GraphQL schema as an interface which has just the declaration but not the definition. So we have to provide all the methods here. So now rather than just uh, theoretically explaining, let me take you to this code. So this is an example of GraphQL schema. Let me, okay, yeah, that's fine. So this is the GraphQL schema of a to-do manager application. And now I have, if I have to create an API for to-do manager, so I have to create an endpoint that should return all the to-do items. Then I should also have a method which will return a to-do item by ID. So you can see here the query part. So here I have added a to-dos field in this query type, which basically return a to-do item, which we have defined here on here. Okay. So this to do is basically a type like a object that we create in JavaScript or .NET or any other language that has all the properties that you need in to do item. So in object oriented world, to do is an object which has certain field, and these are the fields: ID, title, description, and every field has a data type. So it has id is nothing, it is just a string, but since it would be Unix, so that any person who is looking at this GraphQL schema get to know like this is the unique field of this particular object. That's why we are calling it id. And this this exclamatory mark says that this is not null. So anytime you put this um, put this exclamatory mark, you mean to say that this particular uh, property is not null. Like, so ID will never be null, title will never be null. Now coming to the description, it could be null, but these things will never be null, right? So we have couple of data types like boolean, string. These are just scalar type or primitive types that we have in other languages as well. So we have created type to do. Now coming back to the query, we have created a to do query, or sorry, to do field within query type, and this means this is written, this will return an array. And now we have this mark again, so that means this to do's method, or I mean in GraphQL we call this as a type, and the members of the types are known as fields, but these will be the operations. So you can think this is would be a get operation, and this get operation will return an array of to do items, and that would never be null. Like even the items of that array will never be null, and the entire array will be never null. Second operation would be this, where it will return a single item and we will be providing the ID, and it will return the so it is similar to get by ID method. Okay, so these are the get operations, similar to get operations that we have in REST API, and that's why we call them query. Okay, so a query will not have the operations which are intended to modify or delete or update the data. All the get operations of a REST API would fit into query type of GraphQL schema. Second is this mutation. So you also have post method, delete method, put method. All those methods will be part of this mutation, where we have create to do, as you know their name indicates, they have proper input, they return something, and we have create, update, delete. So those kind of data manipulation language DML operations will be part of mutation. Get operation will be part of query. So now you got to know where, what you have to create in mutation, what you have to create in query, and what kind of object you have to create. And one more thing is we also created to do input because this to do has a lot of properties which we were not required when we want input from the user. So we created a to do input which only has these three properties. We don't need created it, updated it, because we know that information at the server side, and id would be auto generated. So now this is just a GraphQL. I mean, this is how you can create a GraphQL schema if you have this kind of information. So it's just like creating an interface. All right. So now the second thing is GraphQL schema definition language. So if someone asks you what is a GraphQL schema definition language or GraphQL SDL, so it's nothing. It's just what you used here. All right. So whatever you are using here is you are writing GraphQL schema definition language to define this schema. So it is nothing else. And you can go over internet and go on GraphQL website to learn more about syntaxes. But yeah, this is the fundamental. Last thing, the supported types that I will cover quickly, though we have already covered, but again I will cover quickly. Scalar types and object types. So scalar types are these types: id, string, boolean. We call them scalar types. Object type is just this, like this to do, which is an object, and this is a type. So we call to do as an object type. Then query type and mutation type. These are the query types. This is the mutation type. Then input type would be used to as an input parameter in this mutation or query object. And then finally subscription type. Subscription type is we are not using here, but it is used to get real time updates from server. So since we are not going to use in this particular video, so I'm skipping this. Enum type, enum is simply, here we are not using any enum, but for example, if we could have a field like status, and then we could create an enum in the GraphQL schema as well, just like other like enums that we use in other languages as well. So these are the types that are primarily used in GraphQL schema definition language. So yeah, I mean, with this, once you have created a GraphQL schema, then you are good to go to further create an AppSync API in sorry, you are good to go to create an AWS AppSync API, because in order to create an AppSync API, you have to first a GraphQL schema ready. All right. So that is the first step, and this is the fundamentals of GraphQL. So now we are done with it. Next, talking about AWS AppSync fundamentals. So we just learned about GraphQL fundamentals, but we have to eventually create GraphQL API in AWS AppSync. Okay, so we have to understand the fundamentals of AppSync, and then don't worry if you feel that there's a lot of theory going on. We will quickly jump into the practical demo, and we'll jump into AWS console, and you will be able to correlate all the things there with the actual implementation. So AWS AppSync has few things, like you see GraphQL schema, data sources, and resolvers. So first thing, GraphQL schema, which you all have already prepared for an API, and you will have to provide that GraphQL schema to AppSync API, right? Once you provide that GraphQL schema, you also have to know, like, okay, so you are creating an API now. You need to know where your data will be stored, or from where you will be fetching the data. So will it be, what would be your data source? Will it be DynamoDB, or your API will be calling Lambda functions, or you will be basically hitting Amazon Aurora, yeah, MySQL, which is hosted on Amazon Aurora. So you can click here, and here we can see a bunch of data sources that are available. So even in this diagram, you can see that okay, let me zoom little bit. Sorry. Okay. So you can see Amazon API Gateway, DynamoDB, Lambda, Amazon Aurora, and you can find a list of supported data sources here. All right, AWS Lambda. So yeah, HTTP endpoints. So you can have those data sources connected with your AppSync API, right? But don't confuse. We are going to use DynamoDB and in this lab. So just stick there. But yeah, I just wanted to let you know, like, these are the available data sources that you can use. Then, so first the GraphQL schema is covered, the data sources is covered. Now the main important thing is the resolver, because I have created a API like to do's operation or create to do. Now how the data, if I call create to do operation, how the data will be dumped into the DynamoDB. So there the resolvers comes into the picture. So they are kind of acts as a glue between your schema and data source. Here you will be writing the business logics that will be basically translating your requirement, or will be inputting or will be inserting your data in DynamoDB, or you will write the code to fetch the data from DynamoDB and return to the end user. So here you will write the business logic. Now you can write resolver in two types. I mean two runtimes. One is the VTL, another is JS. So VTL resolvers are little bit, you know, we can say they are older, and JS resolvers are quite new. So VTL, the full form of VTL is Velocity Template Language, and which is little bit hard to, you know, write the resolver in this language, um, because we are not well versed with that language. However, most of the developers are more familiar with JavaScript. So I personally find to write the resolvers in JavaScript language is quite easier as compared to VTL, and that is newer. And AWS also kind of recommends now to use JS resolvers, and I will show you how to write those resolvers in hands-on lab. So, but yeah, as of now, you should know there are two runtimes available which allows you to write resolvers. One is the VTL and another is JS. All right, so this is the most interesting part of this video, and in this video basically you will be creating your first GraphQL APIs, and we will move to our AWS console, and there we will be creating the AppSync API. But before that, I have provided a link here, and you just have to refer this link. And here I have provided all the steps that you need to follow in order to create the API by yourself. So this is the first thing, creating GraphQL API from AWS console. You have to just, you know, log in into your AWS console and follow the steps. So first we have to create an AppSync API with the below schema. So what you will do, you will just copy this schema from here and go here, and you will just, okay, I don't see AppSync here, so I will just type AppSync and select this. And if you have any API, then you will not see this screen, but you will see this screen. Now, since we don't have any API, let's close this. So I will select this create API, and here I will select GraphQL APIs, right? And in the GraphQL API data source, we will select design from scratch. So we are not going to select any other option. We are learning here how to build APIs from scratch. So we'll select design from scratch. Now my API name is my AppSync API. I am just keeping the same name, but you can change it as per your convenience. I am not selecting contact name. I am not selecting private API, just selecting next. Create GraphQL type. So create type backed by DynamoDB table, create GraphQL resources later. So we'll select GraphQL resources later. Okay. Now select next. Now we are going to review and create the API. So we'll just click on create API, and you have successfully created your first GraphQL API. However, this API is doing nothing, empty API, but yeah, we will make it work. So we'll go here, we are here. So I will again go back, and so this is the API has been created, and you can see, as I was talking about, there you will get a single endpoint. So here's the endpoint available with, you can see like this. So this is the single endpoint, and you will be able to access all the operations with the single endpoint, right? Okay, so I will just select this API, and we'll go here in the schema, and or maybe I can just click here. Sorry, I can go back, and I can also click here edit schema, or I can go back here on the left side schema. I will click on edit schema, and whatever I have schema I have in my uh, gist file here. We'll copy it and we'll first remove this and we'll paste it. All right, and we'll just save this. So now we have created a GraphQL API. We have provided it the schema. So you can see, okay, what is happening? Yeah. So the schema has been created, and now what is the next thing? So next thing is create a DynamoDB table with PK as partition key. Okay, so since we are creating a to-do manager application, so we have to store the to-do task or the pending task in somewhere in data sources. So we are using DynamoDB as a data source in this video or in this demo. So the schema or the data model of the DynamoDB would be something like this. We have a primary key, and in DynamoDB there are two ways to create primary key. We can either have a partition key, or we can have a combination of partition key and sort key. In this demo we are just going to have a partition key, yeah, and we call it as PK, and rest are the attributes. So title, description, completed, created it, updated it. You can see these are basically kind of a one-on-one mapping with these attributes. So what I will do, I will just go in my AWS console and select DynamoDB, and I will go here. Okay, here have one table anyway. I will go here and create a DynamoDB table, so I can call it as to do, and partition key name would be PK. All right, I don't have any sort key which is optional. Default settings, yeah, just go and create DynamoDB table. We have created a to do DynamoDB table which is basically in creating a state, and it is now active. All right, so now we'll go back to our Amazon. I mean, the third point is create data source to connect with DynamoDB table. So we'll go back to our AppSync API. So here in AppSync API we have created a schema. Now we have to create a data source, because if I take you to this page, you these are the fundamentals of AppSync. So we have created a schema, we have created a DynamoDB, but we have not attached that DynamoDB as a data source in AppSync. So we have to do that. So we'll go in AppSync, we'll go in the data source, we have to create a data source here. And what would we to do, or I will call it to do DynamoDB. Okay, this is the data source name, and what is the type of data source, which is Amazon DynamoDB. As I said, you can find multiple data sources here, right? And the reason is AP South 1, and here is our table name to do, right? And I am going to create a new role because I don't have an existing role, and this role basically will allow AWS AppSync to interact with DynamoDB. All right, so just allow it, create. All right, it doesn't support, so we'll just add in the underscore. Let's see. Okay, so now we have created a data source, which is this. The schema is there, is already created. Now we have to create resolvers, right? Okay, so the data source is created. Now we have to create resolvers, and the resolver has to be created in JavaScript, right? And the resolver, so because this is a demo, we are not going to create a full functional app. So we will just create resolver for two things. One, for to do query operation, which will basically return you all the items that are stored, or all the to do items that are stored in DynamoDB, and a create to do operation by which we would be able to create or insert the data in DynamoDB table. So with that you will get an idea like how to write resolvers and how resolver works. So we'll go there, right? So how to write a resolver? So first go to schema, and basically what happens, since this is a schema and I cannot, okay, I will go here instead. So here you see we have two operations in query and three operations in mutation. So think you have to create one resolver for each operation in query and mutation. So it is a one-on-one mapping. So for example, we have 2 plus 3, 5 fields or 5 operation in query and mutation. So we have to create 5 resolvers each for each method or each operation. So we are going to create uh, 2 resolvers, for one is for this and one is for this. So for this or maybe for create to do, we will create it first. And what I have uh, noted here, so use TypeScript resolvers given below and convert them to JS. So I have created resolvers in TypeScript, and we are going to convert them to JavaScript. So I will just go below, and I will go here, and sorry, where their resolvers are. Yeah, so this is the create to do resolver, and I just need to copy this. I will copy this create to do resolver, and on sorry, create to do and to do. So this is the to do resolver. Sorry, I have to first select create to do resolver. So I will select this and will go on this website, which will basically convert this entire TypeScript to JavaScript, and this is converted. So we'll just copy this. Okay, don't worry, I will show you how to write these resolver, but as of now that doesn't matter. And even I will also show you how these resolver works. So we have copied the resolver for create to do item. We'll go here, and in a schema, if you scroll down, sorry, why I'm not able to see actually. Let me reload this page. uh Okay, I'm not able to. Okay, yeah, here I have to search by. Ideally, I should be able to see. Let me anyway. So I will search create, or why I'm not getting. I just want create to do. So here you will see a list of the resolvers. I mean this list of the fields where you can attach the resolver. So this is a create to do, and I will just click on attach, and here on this screen you have to attach the resolver. So you have to select the unit resolver. Pipeline resolvers are little different, but as of now just select the unit resolver. So here, as I said, there are two types of runtimes. One is the JS runtime, another is VTL. Select AppSync JS. In the data source, select to do DynamoDB, then select create. Once you select create, so the resolve sorry, yeah, you can see the resolver is created and the code is here. So here's AWS also teaches you how to write JavaScript resolver. So if you see here, you can find, like, if you have to create an item in DynamoDB, how would you write? So it will provide you the syntax, and then you can learn from this syntax. Like for put item, how would I write? For if I need to delete an item, how would write a resolver? So you can learn from this sample code as well. However, AWS has published this utils library, and which is having all the important methods that you need to write resolvers in JavaScript, because you don't know. Okay, I will come that later, but yeah, as of now just delete it and paste the JavaScript resolver that we have copied from here. And this resolver is basically has two things. One is the request function, another is response function. So we call it request handler and response handler, and we'll just save this. All right, so resolver has been updated. All right, okay, so this has been done. Now we'll do the same with the other resolver, which is to do query operation. So we'll go here and selected to do's, this one, copy it, delete it, paste it, and this is updated. We'll copy it. We'll go back to AWS AppSync. We'll go in this AppSync schema. Here we'll select to do's. In query we got one item. Yeah, here it is. Select attach unit resolver and select the data source as to do DynamoDB. and create, and it is created. Now just go here, remove this entire resolver code, paste this code there and save this. So you have completely created your API, and I will also show you how you can invoke this API. But now let's understand how these resolver works. Okay, so in order to understand the resolver, okay, I will just first go here, or maybe I can show you, or I can explain you from here where I copied the resolver. So I will just go here, just a second. Yeah, create resolver. So this is create to do resolver, and this is written in TypeScript. So just understand it from TypeScript point of view, and that doesn't matter even. So in a resolver we have two things. One is a request handler, another is response handler. So this is the request handler, which is a simple function in AppSync or JavaScript function, and another is a response function, and we call them request handler and response handler. Next thing is the context. So whenever a request is coming from here, or anytime if a user, for example, is calling create to do operation from the API, so what will happen, your request will come to this part, okay, and this particular things will be executed. Now what you might be asking, what we will be getting in context, because this context is coming from AWS AppSync utility, and we should know what kind of properties we will have in this context. So if you go to my nodes here, you will see that this is the context object, and this context object has everything, like it has arguments which you will be passing from the client application, and identity. If you have configured cognito, then you will get cognito username here and other properties. And oh, okay, so these arguments or identity you will be getting in request handler, but the same context object is also being used here in the response. So few properties are being used and will be available only in request, and few properties like result, error, these properties and previous, these properties will be available in response. So you will get to know, or even you will be working in TypeScript, you will get to know like what kind of properties will be available and how to use those properties. So this is how the request will be coming in your uh, request handler, right? So this is about context object. The next thing is what is your return type. So since you are I mean your request handler is executed, so you have to return something from here, okay, because your request will basically go, you made a request here, it came to GraphQL schema, create to do, it executed your handler. Now your handler request function is executed. Now it has to go to DynamoDB. So because here is your data source, it has to go to DynamoDB. So here you have to return something or a request to DynamoDB, or it would be an object that DynamoDB can understand and respond accordingly. So if you are using DynamoDB, then you will get DDB. For example, we are using, in this context, we are inserting the data in DynamoDB. That's why we are using DDB put, and DDB is basically coming from AppSync utility. So you have to, depending upon the data source that you are having, you have to return a specific data type or a specific type. Uh, what I would say, a specific type or data in a specific type that the background or the underlying or the next data source should understand. So if you would be basically executing a lambda function from your resolver, then yeah, the return type would be different. And how would you identify like what data type or what data type I should use for a specific data source? So that you can also find from here, the return type. So for every data source, AWS has a defined as a structure that you should use. For example, you are sending a request to DynamoDB, AWS Lambda, then you should return the data in this format, where operation will be one property whose value will be invoked, and the payload would be the payload required for the DynamoDB. All right. So here we are using DynamoDB. So we will be using this. Now once this request has been sent to DynamoDB, it will execute the request, it will return the response, and the response will be coming here, and at that moment the response handler will be executed. All right. So this response handler will, I mean, has multiple properties as I said. But if the error is set, then um, if error has some value, then that means there is some error, and the query has failed to get executed successfully. So we can just return the error from util.error. But if everything is fine and the data has been inserted successfully, or the operation has executed successfully, you will get the response. And the response you will get, then you can return the response from this response handler. And an important thing to note here, the type of the response or schema of the response that you are returning from here must match with your schema which you have basically defined here. For example, this is the create to do operation, so you are returning this to do, and the schema of to do has uh, looks like this. So where we have id, title, everything in a small case, so you have to return the data in that particular format. So you see, we have these, we have mapped the response that we are getting from dynamodb into a format which would be, which we have defined in graphql schema. All right. So that is the requirement. Otherwise, this request, I mean, AppSync will consider this request as an error response if the response that you are returning from here doesn't match with the schema. So that would be, result in a failure or error. So this is how the request and response handler works. Now we'll go back to our AWS console and we'll execute this API. So we'll go in query section, and here you see to do's. And what I will do, I will select the fields. All right. So I will select the fields to do's, and I cannot see them here. I don't know. So anyway, so if I just, okay, query to do, so I will just run this my query. Okay. Mhm. Why it is not getting updated here? Give me a minute. If I select this, okay, I don't know, but yeah, okay. So what we are doing here, let me pause and make this screen little bit uh, you know zoom. So yeah, now you can see the screen. So I have zoomed out little bit, but now I want to execute this query. I mean, you can see the fields that we have defined in our schema are now visible here. So the query are here, and if I select mutation and add, then you see the mutations are also here. So I want to execute the query, and I will select the to dos and will select the fields that I want to be returned from the API. So I will just remove the mutation for now. And so this is the syntax of executing a GraphQL API. Here we will select the operation, and here we'll select the fields that a GraphQL API will return. Unlike REST API, which returns all the fields, here we have the ability to control what kind of fields the API should return. All right, so we have selected these fields, and we have selected the to do's operation or to do's field. So, and in the bracket we have selected all the fields that we want the API to return, and we have wrapped entire thing into this query and my query. And my query, it is just a name. I can name it anything like query one. So like it is just like this query and query one. So I will have query two, and in query two I don't want completed and create at these fields. So just like this. So I want to execute this query one. So as of now I don't have any data here. So even if I execute query 2, I get the same result. But if there were data, then I got 3 fields in query 2, and uh, 5 fields in query 1. Now we will insert some data. So we'll just go with the mutation. So I will remove the query 2, and I will go and add mutation, and we'll just collapse it, and I will use create to do, and here I will just provide the input and also the return type. So ID and title, I want just ID and title in the return. So the ID and title are here, and this is the method, and here I am providing the input. So in the description I will just do the sample description, and in the title, because this is to do item, so I will just type mobile recharge as my pending item, mobile recharge. All right, and what I will do, I will just execute this mutation, and you see the data has been inserted successfully in DynamoDB, and we got an ID. And now if I just execute the query, which is query 1, sorry, query 1 is disturbed, I have to reselect it. So query 1 is to do's, and if I select it again, so you see we are getting the data from DynamoDB and in the get all data. So if I just again insert one more item in create to do, so for example mobile recharge, again electricity electricity bill. All right, so if I just execute this mutation, so electricity bill, another to do item has been inserted, and we can see we are getting multiple items in array in to do. So we have successfully created the API, we have successfully written the JavaScript resolvers, we also understood how do they work, and we also have executed our API and saw how these API works, and we are getting the data from DynamoDB table, and we can also go here in to do table and see explore table items to verify the data, and you can see the data is here, sample description and electricity bill, mobile recharge. All right, so we are done with our hands-on lab, our first hands-on lab, where I just explained you how to build GraphQL APIs with AWS console. So we just learned how to create GraphQL APIs in AWS AppSync through AWS console. Now in this section I will show you how to create GraphQL APIs for AWS AppSync using AWS CDK. So this is little advanced topic and require little knowledge of AWS CDK. In this video or in this section, you will also learn how to write TypeScript resolvers. So if you want to skip this topic, then you can skip. But if you want to learn advanced thing or want to do the real development in AWS AppSync, then you must watch this section. And I would highly recommend to watch these two videos, which is by Michael Lindo, who is senior developer advocate at AWS AppSync. So they will be super helpful. All right, now we'll just go to this link, which is the same gist file that I was using. So now we will be creating a CDK project in TypeScript. So what I will do, I will just go to my desktop, I will open this demo folder, and I will open CMD. All right, so what I will do, I will create a backend. Okay, backend directory, I will move toward this backend directory. And then what is the next thing? Okay, I have to create a TypeScript app with this command cdk init app language TypeScript. So this will create a TypeScript I mean a CDK application in TypeScript language. So let it create the application. Meanwhile, let's go back and understand what are the next steps. So once the application is created, what we will be doing, we will be first creating a GraphQL schema file with the above content. So uh, right now, I mean earlier we just went there, created a schema here through the console. So we since we are going to do or deploy this API with CDK, so we are not going to use AWS console. So what we will be doing, we will be just copying this schema file into our code and will deploy this entire API through CDK. So that is the first step. The second step is this install these npm packages. So And okay, I will show you, or I will explain you why we have to install this CDK construct. But before that, just move to the step 4. So what resources we are going to create? We are going to create a Cognito user pool for security or for storing our users, and this is user pool client. This is the DynamoDB table, and this is the Amplify API. So the API that we created manually, we will be creating through code. And here we have just provided the reference of the schema GraphQL file that we will create in our directory. And we are going to secure this API with Cognito. So we have defined the authorization modes as Amazon Cognito user pools, right? And finally, we will also attach the DynamoDB data source that we created, DynamoDB table that we created with this amplified data source that we all these things we did manually in our previous hands-on. So we will do all these things via code, because when you work in a production application or uh, in an environment where they want more automation rather than doing the thing manually, so these things will be very useful at that moment. Let's see our application is created or not. So our CDK application is created. Now what I will do, I will just open this application in Visual Studio Code, and here we go. Okay, I trust this folder. Now I'll close this, and here what I will do, the first step is to create a schema.graphql file. So schema. All right. Now, sorry, minimize this. Go here and copy the schema content. Copy the schema content. Paste the entire content here. All right. So we have created a schema.graphql. Next step. Next step is to install these npm packages. Okay, so I was saying like why we need to install this GraphQL construct, because what it will do, if I don't install it, I won't be able to create this amplify GraphQL API. So let me show you. I mean, let me first copy this code and paste this code in our backend stack. So here, basically we will be provide the construct CDA construct for all the resources that we want to create. So I have already, sorry, the formatter is not configured here, but okay, let me manually format this. So yeah, anyway, so let me resolve these modules. So the module for user pool is Cognito account recovery, and anything else table, this would be resolved from DynamoDB. Attribute type again from DynamoDB billing mode. So you will have to resolve the modules, and as I said, you have to install the module in order to resolve this amplify GraphQL API, because that is not part of core CDK library as of now. So you have to install this npm package, and that we will do now. So we'll just go in terminal. Sorry, where view, where is the terminal run? Mhm. It should present here. Give me a minute. Command. Okay, I mean, I will run the command from here. I don't know why the terminal is not appearing, but yeah, we are installing this npm package from here. And once this npm package is installed, we would be able to resolve this constructor as well. Meanwhile, I am looking at, uh, I mean, why I am not able to see the terminal. Yeah, I was able to find it. Actually, it was hidden here, so I will open the new terminal. Okay, so the npm package is now installed, so I will minimize this, and I think I should be able to resolve this API now. So you can see I can import it and I can also import this module. So I think everything is done, looks good. We'll remove this code, so we are good, right? There is no error. Now what is next? Now we have to run CDK deploy to start the deployment. So what I will do, I will just go here and run CDK deploy. And this CDK deploy, what it will do, it will basically just compile this or synthesize this code into CloudFormation template and deploy it to my connected AWS account. So rather than me creating the GraphQL APIs in AWS console, now all the APIs will, or all the other stuff, AWS resources will be provisioned automatically with this CDK code. Okay, if you don't know or if you have not worked with the CDK earlier, then you can go to my YouTube channel and look for getting started with AWS CDK and watch that video. I will also provide the link in the description below. So the deployment is in progress, and what we will do, we will basically just delete our previous API, so that, you know, because we are not going to use it any further, so we'll just delete this meanwhile. So the API is deleted, and I will also delete the DynamoDB table that we created earlier. So this is to do, and you can see the backend stack DDB table demo is just created, which is through this CDK. All right, we'll create, we'll delete this to do table, and I will just type confirm. All right, it is getting deleted, and if I go in my cloud formation and stacks, so you will see backend stack, which is just deployed 13th May, which is today, and it is just deployed. And I can also see here, okay, here we got GraphQL API endpoint as well. And so everything, all the resources are now deployed, and this time our API is secured with Amazon Cognito. All right. So I will go to AppSync and will show you one thing, which is, so this is our API which is recently created, and here is our data source, which is Amazon DynamoDB data source. And I don't know from where this came, but anyway, and here the schema is this. So here you may find a little other things as well, but if you just copy this, or if you just scroll down, ignore it. I'm not sure from where this is coming, but we can just troubleshoot it once we get time. But anyway, your data source you will find, sorry, your schema you will find from starting from here to do to this query and mutation, and you have provided this schema here. So everything, and I mean everything, rather than deploying or provisioning the resources manually, you have provisioned those resources through CDK. Moving to the next thing, as of now we have not attached any resolvers, so this API will not work. Next thing, we will learn how to write resolvers in TypeScript. So generate types using Amplify code gen. All right, so basically we have created these fields, like uh, we have created to do item, to do input item, which has three properties: title, description, completed, and to do object, which has these properties. So we have to write resolvers, right? And if you see earlier, if I show you the previous resolvers that we use, so we have to basically insert item in DynamoDB, and we also have to return that data from the API. So we have to create types. Similarly, like we create DT objects in .NET that just has properties, or POCO classes that just has properties. So we have to create those properties, all right, or sorry, those classes. So if you see, if I show you here to do resolver, so we have to return the data in a format, like we need a type to do, which should be defined somewhere, so that we can basically return it properly. And this to do type will basically map to the type that you have defined in GraphQL schema. So for every GraphQL schema type, like object type or input type, you have to create a respective type in your TypeScript code. so that you can write the resolver properly. Otherwise, you won't be able to write resolvers with type safety manner. So what AWS do is AWS helps you to generate those things, or those types manual, I mean using automated code generator, so that you can easily write resolvers in TypeScript. So let's do this practically and then you will get to know. So what we are going to do, we are going to generate types using Amplify code gen. And even if you go here on AWS AppSync API, and you see that they say integrate with your app, create a client, and they also say, generate the entire code uh, to connect with this AppSync API. So if you are using Angular application, it will generate all the code. You just need to call the method. So you don't have to write code manually. We'll come there, but before that, just learn how to write resolver. So just go to the directory where GraphQL schema is. We are already at that directory level. So I will clean everything. Now, if CodeGen is not configured, run this command. So we'll run this command, and this is add. So it will look for a GraphQL schema file and will, ask us certain questions. So it is asking choose the type of app that you are building. So it is not iOS, it is not Android, it is a CDK application, which is basically in TypeScript. So we will select JavaScript, and then what JavaScript framework you are using. Since we are not using Angular here or any other framework, because this particular application is a backend application to deploy the backend, so I would select none. Then I will select TypeScript because we are using TypeScript here. Then I will select just enter. I will just select the defaults. And so now what it has done, it has created a few files here in src folder, and here inside GraphQL folder as well, which is the subfolder of src. You see all the queries that we were writing earlier in query editor. So it has provided the strongly typed uh, types, or strongly typed definition for those queries and mutation. So we can just use these types directly in our code to invoke, or to invoke those queries and mutation. But now we'll just ignore these queries and mutation. We'll focus on api.ts file. Here we got those types: to do input, to do. So we will have to use these types when we are going to write mutation. All right. So the next thing is to, since we have successfully completed this step, we'll move to this step using TypeScript resolver. All right. So first, what we will do, I will go and create a resolver, like create to do resolver. Okay. I will start with the step 4, and where I will write, I will start with the step 3, where first I will create TS resolvers folder. And why I'm showing you all this, because you don't have to manually create resolver, and it would be very easy to write resolver in TypeScript. So I will create a folder TS resolvers, and then inside TS resolvers I will create a file like this. And what I will do, I will just copy this code and then explain you what I did. All right. So as I explained you earlier, this is our request and this is our response handler. And this create to do resolver will basically execute it when someone try to execute this create to do operation. And sorry, yeah, this to do create to do operation, or this mutation. So now if someone execute this create to do operation, then we will get an input, or we'll get the data for this to do input. So here we will be using this create to do mutation variable, and if you press F12 here, so it has already identified that the to do input would be required, because if you see, this is input type. Okay, this is input a property, and the type of input is to do input. So here you see input is a property and type is to do input. if we have multiple properties like update to do, where two properties are there, id and input, so we have another class or another type where we have two properties, id and input. So all those things have been automatically created or converted into typescript with amplify code gen that we just used in previous step, so that we can write typescript resolvers very easily in type safety manner. All right, so this is the request part. Now someone will send us the input, and what I'm doing here, I am just getting the title input and I'm just using the input dot title property to access the incoming title, incoming description, incoming completed value from the input type. And for the rest of the things, pk completed, sorry, pk updated, created, I'm using these utility items. And for this utility item, I will have to install this npm package. And why I'm, why I'm just structuring in this way, because if you notice that the DynamoDB structure that we created earlier, which is having the pk title description and these properties, so here I will be basically constructing the object in a format that I will be inserting the data in DynamoDB. So here I'm using ddb.put, and here this is the key, which is the primary key of DynamoDB table, and here's the item that I'm going to insert in DynamoDB. And this ddb.put will basically return the request in a format which of this type, so DynamoDB put item request, and then this request will be sent to DynamoDB, and then the response will be received here in response. So now let's resolve the missing things, and then we will move to the response handler. So I will go back here in TypeScript resolver. We have executed step 3, step 4, but I have to install this NuGet package as a dev dependency. So I will go here and install this package. As I said earlier, that AppSync has created this NuGet package to help developer write effective code in TypeScript. So you see, the moment I install that NuGet package, all the utils have been now resolved with this util library, and it provided context, and with this we get intelligence, like because this is a context, and now we know that if I type ctx, then I will get args, and I will get input, and I will get complete, and all those properties I would be able to get here. And if I want to insert the data, if I want to delete the data, I can write the code accordingly here. I have types defined, so everything, you get a strongly type support with this uh, this library. Otherwise, if you will be using, basically writing the resolvers in javascript, then you will not get the IntelliSense support. And if you don't get IntelliSense support, you won't be able to write code, because you don't know what property exists and how will it work. So that's why it is very important to write the resolver in TypeScript. And then we'll also see how to convert these resolvers into JavaScript, because AppSync.js runtime doesn't execute the TypeScript resolver, that only understand JavaScript. But for the developer experience, we have to write the resolvers in TypeScript. Okay, so moving to the next step. Yeah, so I also created another file, DynamoDB entities ts, because you know this is to do entities coming from there, and I will also give you a reasoning why I did it. So I will copy this. Now the format that we are going to insert the data in DynamoDB, and the format that we are maintaining in GraphQL schema will be generally different if we are writing a real world application, not a just demo application. So you won't be doing one-on-one mapping the structure, because here in DynamoDB we will storing the partition case pk, and we can store different types of item in a single table. So we won't keep it id, or we won't be a bit have a mapping of this, like we will not have a structure like this. So the structure of this object and the items that or the structure that we are going to maintain in DynamoDB made different. So we have to map the incoming value i- from schema type to a DynamoDB type. That's why we are maintaining it separately. So that's why I created these DynamoDB entities and define the type there, which is this export to do entity. Now we are creating a to do entity, and we are mapping the incoming input parameters value to this to do entity, and we are returning this request to DynamoDB. DynamoDB will execute this request and will return the response here. Now we'll check the error property. If there's some value, then we'll basically return error. Now if everything is good, then we'll get the result in uh, you know in dot result property. And normally, I mean, not normally, I mean, we'll get this because the item has been inserted, so we'll get the to do entity, the same item back with the same format in as a response. And we can't directly return this to do entity, because we have to return, again, as I said, we have to return the item in a format which GraphQL schema has defined, and that is something to do. Again, this to do is basically coming from this auto generated code, so you don't have to maintain the types for your GraphQL schema. They have been automatically generated for you with the command that you run in the step, I guess, in this step. Okay, so if there is some change in GraphQL schema, then you will just need to run this command again. Just don't do add, just run this command, npx amplify cli code gen. Yeah, this one I have already written here. Okay, so we will return the to do from here with the type, return type, and we will map this to do entity in that to do item, and we'll return it from here. So this is how we have written create to do resolver. Now I will also write sorry, where we were here using TypeScript resolver. So I will also write a to do's resolver, which is equivalent to uh, the one which returns all the to do items. So I will just create this file, and I will not explain it. You can just go through the code and understand it. I mean, this is quite explanatory automatically. Now, okay, so we have done it. So we are done with the step 2.4, where we were, I have shown you how to write TypeScript resolvers. Now the next thing is we have to compile the TypeScript resolver to JavaScript 2.5. This is a step, but before that we will write, I mean, we will just complete the step number 2.6. So what we will do, we'll just go there in our CDK code, and we'll just update the code with this value or this particular code. So I will go in backend stack, and here, I guess here my formatter is not working. I don't know why, but I will try again. Oh, yeah, I will use this. Okay. So my, I mean, I have just added this code, and this code, why I have added, I will just first resolve the missing thing. So I will just do this AppSync, and okay. So now what I'm doing, I am adding the resolvers. So one is the mutation, which is create to do. Field name is create to do, which will basically we have defined in a schema.graphql. And how, from where the code should be coming, it would be coming from JS resolvers and this JS file. And similarly, we have added a get to do resolvers. The name could be anything, but this is the query type, and the field name is to do's, and runtime is JavaScript runtime. The code is coming from JS resolver directory, which as of now doesn't exist, and the file name is to do's resolver.js. Okay, all right, this is good. But now, as of now, we have just code in TypeScript in TS resolver. We don't have code in JavaScript. So we have to first convert this TypeScript code into JavaScript, and then have to redeploy this CDK stack so that the resolver can also go into the AWS. So that's why I just went with this step uh, uh, prior to 2.5. So we will go back to the step 2.5, where I will show you how to compile the TypeScript resolver into JavaScript. First, you have to install these two NuGet packages, npm packages, which are the dev dependencies, uh, esbuild and glob. So they are getting installed, and I have to create this pre-deploy mjs file, and I will show you why. We are using mjs because we want to use es6 feature, we want to use import statements, so that's why we kept the mjs extension. Why I kept pre-deployed .mjs, I will later tell you the reason. So first I will copy this and paste it. Now the dependencies have been installed, and what it is doing, this es build, this code particularly. So first we are just getting all the files from ts resolver folder, all the TypeScript files, and then we will use ts build will use es builds build function to compile those files into JavaScript, and uh, we are dumping them into this output directory, which is js resolver. And yeah, that's all. And I mean, you just have to ignore the properties, or if you want to dig deeper, then you can do. And external is something, yeah, so when converting this into JavaScript, don't convert this, because this is an external dependency that would be already available into AppSync JS runtime. So just ignore this, that's why we put it in external. All right, then what we'll do, uh, we will do, we'll go in package JSON and add these two commands. Okay, package JSON is here, so we'll go here. uh, Alt Shift F, I guess. Alt Shift F. Oh, why it is asking again? Okay, so I have run this. I mean, I have formatted this and I have pasted these two new lines. So earlier, we to deploy the stack we were using CDK deploy, but now we will use npm run deploy, because we want this compilation of from TypeScript to JavaScript to happen first. So for that, we have added one more command, pre-deploy, right here. So what happens when we run npm, for example, npm run deploy? So the Node.js runtime will identify this. If there is a command with pre as a prefix, then it will execute that command, and that command will basically execute this node pre-deploy mjs file which I created here. And that's why I just named it as a pre-deploy. You can name it anything, but it's just understood by looking at the name, like when it is run. So it will run just before the cdk deploy, and it will compile the TypeScript code into JavaScript, and then it will basically execute the cdk deploy, so that those files will be available here at the time of the deployment. All right, so I will just save it, and in order to directly execute pre-deploy, we can just run this and see whether the files are created or not, JavaScript files. So you see the JavaScript files are now available, and we don't have to go to any other website and type code there to convert TypeScript code in JavaScript. We can just run this command. Okay, so the files are now ready, and what we'll do, we will just run this npm run deploy command that eventually will run cdk deploy. So I will just run npm deploy command, and this will deploy the latest changes to AWS. And if I go here, you will see the schema, and it will take some time to propagate. Okay, it is updating. So it will add those changes in AWS, and then we will basically test it by doing query. So I will just zoom out it little bit. Okay, so what we will do, we will select, okay, first we will insert some item. So I will, okay, I just did it twice. I will remove all these, select mutation, and we'll select create to do. And here I'm providing inputs, and these are the items I want in return. In the description, I will just say description 1, and this is title 1. And I if okay, deployment is finished, then now I will just execute my mutation. Request. Yeah. So since we have put a Amazon Cognito user pool, that's why we are getting 401, because we this request is not authenticated. So we have to create a user in uh, our Cognito user pool, and I will go there and create a user. So this is 24 minutes ago it is created. So I will create a user here, and don't send invitation. I will provide my email, and I will add a password here, which is kind of, I won't tell you. So I set the password. I'm marking this email as verified, and I will create a user. All right. So the user has been created. Now, okay, it will ask me to change the password. Okay, so meanwhile I'm doing this stuff, I am pausing my video and will back once everything is done. Okay, so I'm here. I will click here. So I'm just trying to execute this, and now I'm I will log in with my user that I recently created. So I will click here, login with user pool. I will select the client ID, and I will provide my username here, which is my email ID, and I will provide my password, which is the one that I provided at that moment, and I will do the login. As it is asking me to update the password, so I will just do one more thing. I'll just update my password, and I will do login. So now I have logged in. Now my token would be present. So what I will do, I will just run this mutation, and you see the mutation has become successful, and I have just inserted this item. Now I will create one more item, and I will just execute the mutation again, and the two items now have been inserted. And why it is getting successful? Because we have successfully deployed our TypeScript resolver with CDK. And even if we can run the query, or just remove the mutation from here, run the query, and you see the title here, and my query, you are getting the items in array, two items, title 1 and title 2. So yeah, and I can also show you one thing here. So this is our I will again little, so this is create to do. Why it is not showing? Okay, I have to refresh it, I guess. So you see create to do, the resolver has been there, and if you go, the this is the TypeScript code, and this is the converted code that is coming basically from JS resolver, which is in create to do. And this is, you can see entire thing, the source mapping URL you can also see here. So this is how basically you can write the resolver in TypeScript and deploy them. So you don't have to manually writing the resolvers, and the whole developer experience of since the beginning, from provisioning the AppSync resources and Cognito, DynamoDB, and writing resolvers in TypeScript and using CodeGen to automatically generate those types. Entire developer experience would be so smooth, so that you can quickly write APIs in GraphQL and deploy them on AWS AppSync. So we are now done with the second hands-on lab, where I showed you how to create and deploy the APIs, GraphQL APIs with AWS CDK. The last session, in the last hands-on lab, I will show you how would you consume these applications in Angular. So we are in the last segment of this video, where I will show you how you can consume or integrate this GraphQL API in your Angular application. So just come to this point and click here. This will take you to this gist file, and which I have already opened here. So we'll just follow the instructions given here. And the first instruction is to just create an install Angular CLI. So what I will do, I will basically go here on the folder location where I have created my backend. So I will just open the command prompt, and we'll start executing these command. So I have already installed Angular CLI on my machine, so I'm not going to rerun this command. But if the Angular CLI is not installed, then you have to run this command. After that, what we will do, we will just run this command to create a new Angular project. And why I kept the name as frontend, because I want that a frontend folder should be created here, and my Angular application should be inside that particular folder. Now I am adding this no standalone because with Angular 17 and above, if I don't add it, then it will not create an app module.ts file. So we would need that file for the demo purpose. So that's why I am adding this no standalone uh, parameter here. So what I will do, I will just run this command and let the Angular application be created. So I will select SaaS, and I don't want server side rendering, so I will say no, and it will take some time to create this application. Now meanwhile we will go through the third step. So once the application is installed, we have to install these two npm packages. So first one is AWS Amplify, and second one is AWS Amplify UI Angular. So AWS Amplify is basically a framework created by AWS so that you can use this framework in your front end application such as React.js, Next.js, Vue, Angular, Flutter. It provides a set of libraries that makes it very easy to interact with backend AWS services such as AWS S3, AWS AppSync, and Amazon Cognito, and other services which are supported by AWS Amplify. So this is a library which has a lot of methods which makes your development easier. The second component or the second package that we need to install is this AWS Amplify UI Angular. So because we are using Amazon Cognito and we have to create a UI so that users can log in and register themselves on your application. So AWS Amplify UI Angular is a package that provides UI components available to your application. So we will use them in a bit, but yeah, let's see whether application is created or not. So application is created. I will just move to my front end folder, and I will open that folder in Visual Studio Code. Okay, so it will launch Visual Studio Code, and then we will copy this command and we will install these npm packages. All right, so we can see uh, this file is previous file, so we don't need it. So here the new application is available, and we will just go to the terminal and we will install these npm packages that we just discussed. All right, so let these packages install. Next is we need to basically configure Amplify in our application. So we have to copy these copy this particular code in our application, or you can also just refer this documentation where they have explained how to set up Amplify authentication or Amplify app, Amplify in your front end application. So here, if you just scroll down, connect your application code to your auth resources, so they are also using installing the same npm package. Now in app module, if you see what they have done, they have used Amplify configure method, and they have added in the imports module, they have added this Amplify authentication module. And I guess yeah, I have not added that step here, but yeah, you can follow it. So first what we will do, once the package is installed, okay, the package is installed, we'll go to the app.module.ts, this, and I will just move it little below. In the providers, I guess I should add this here. So I will import this here, and then in import section, sorry, not in provider, I have to edit in import section, so I will edit here, and then I have to write Amplify configure. So Amplify configure is basically getting the output from JSON. So since we are not using AWS CLI, uh, uh, because that creates a file that we can just pass to the configure, rather we will be providing configuration manually. So what we will be doing, just before this ng module, we will write this code, and here we will call configure method. So here we have to provide configurations of Cognito user pool and GraphQL endpoint. So that we will do, and for that we will go here in our Cognito, and this is the user pool. So I will select the user pool ID, select this user pool ID, and then I will go and select the client ID. So in the app integration, I will go and will select the client ID. All right. Now we have to provide GraphQL API endpoints as well. So I will select AWS AppSync. It is AppSync, and I will copy this GraphQL endpoint and all goods. Since this API is secured with Cognito, so we have just provided user pool, and the Amplify local library or the framework is smart enough to know that this authentication, I mean, it will use this authentication information to basically pass the JWT token to the endpoint automatically. All right, so we have configured this AWS Amplify. Now what is next? So we have to create a UI page, because if I run this application, for example, if I run just ngser, so it will run the application, but we have not added any UI component to so that user can log in or register themselves. So application is available, and I will open this. So this is a new front-end application, Angular application is available. Now what is the next step? We have to use this CSS. Okay, so okay, I will come here later, but before that I just want to go below and add this amplify authenticator component, this amplify authenticator component in app component.html. So I will go in app component.html, will remove this entire code. So once I remove this entire code, you see this application becomes empty. Now what I will do, I will just copy this code, and you can see this application is, it, the component is created here, but the CSS is not properly available. So what we will do, we'll just go here, and I think they have suggested to add some CSS, so we'll go here and add this CSS in style SAS, sorry, here. And I think there is some issue, that's why I have added this particular CSS. So let's see which one works. I mean, I will try this one. There is some issue, so that's why I have added this. So now the CSS, I guess, has been considered, and if we go here, you can see the UI has been updated. So you can use this particular CSS rather than using this CSS statement. All right, so now you can see you in a few minutes you have created a fully functional login or registration screen. And now what we are going to do, we are going to, since we had, I guess we have not created any user, but we will create a user in amplify in Cognito. But before that, what I will do, I will because I want to consume the API, so I will generate the proxy so that I can use the API. So I will run this npx amplify CLI code gen, and here I will be providing API ID, and the API ID is this. So sorry, where it is, yeah, here. So I will copy this command, will go here, and I would open one more terminal. So this is one, and this will basically generate the proxy classes so that we can consume the API. So please download the GraphQL schema or schema JSON. Okay, so since our GraphQL schema.graphql file is not present here, so we have to bring that file here. So what I will do, from the backend schema.graphql, I will bring the file here, but I think it should download because we are providing the ID here. Please download as soon as schema JSON and in place. Anyway, if it is not downloading automatically, we will download it. We'll just copy it from the backend, but you can figure out, I mean, if we are passing the API ID, then it should automatically download, but it is not downloading as of now. I'm just not going in troubleshooting because that will take more time. So I will just run this command, and this will basically generate it will ask us a few questions. So here it is asking what kind of app you are building. So this is JavaScript. Here you will say Angular application, because earlier earlier I selected JavaScript. Earlier I selected none because we were developing CDK application, but this is an Angular application, so we'll select Angular. Then again choose the code generation target, so I will select Angular, and then I will just select yes, 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 yes. Okay, so it has generated code files and API service.ts. So if I go here and site API service, it has added all the methods so that we can easily consume, or it kind of generated proxy classes so that we can uh, consume the API using this API service.ts file. Now there are certain issues in this file so that I had identified earlier. So we need to just remove this gen observable because that is not being used. So we'll comment it, and we have to write this 2 lines of code because yeah, and this API we have to remove the API, or if it is working fine then it is fine. Yeah, earlier there was issue in this API, so uh, we don't need even this generate client, so we'll remove it. So you just need to comment one thing which is not being used, or we are getting errors. So why we are getting errors, let's see. We are getting error because yeah, api.graphql is not working. That's why I guess you need these 2 lines. So I will go here and just add these 2 lines, and you can just remove the API from here. So once you add these 2 lines and remove the API from above and use this API, all the errors will go. And now what you can do, you can just go to the app component and start consuming the API. So you will come here in the app component, just replace the code with this code. So here, sorry, here just write this code inside app component, and I would say Control Shift F. Then now I will just resolve the import statements, this to do input. All these things are coming from API service. So what essentially you are doing is uh, you are basically creating an object of API service which is in injectable service, you can see, and that is auto generated. So now in ng on init you are calling create to do operation, and create to do will basically return a promise, and then promise can be successful or it can throw error. So we are basically creating a to do item, and this to do item, so the methods of GraphQL schema are now have been turned into code, and that you can just auto generate with the CLI. And so we'll create a item. So let's see it if it works or not. And I would say that this would not work it because our API is basically authenticated, so they will be throwing no valid or token. So we have to create a new user. So what I will do, I will go in my cognito and will create a new user, or I can also create a new user from here. So let me do it this way, Ankush Jain. uh, I guess it should work. And I user already exists, maybe I have created a user, yeah, because we did the testing and at that moment we created a user, so the user is already available. So I will go here and will log in, and I, if I remember my credentials properly, then I should be able to log in. Yeah, so I have been logged in, and now if you just re refresh this page, then you will see a to do item has been created successfully and we have got the record. All right, so this particular section has been executed because we are getting the ID, and uh, we can also verify it from DynamoDB table, though we don't need to verify because we are getting ID, but yeah, we can verify. So if I go here and this is my backend stack. So the description 1 and description 3, sorry, description 1 and description 3, or title 1 title 2, those are the records that we created when we were testing through the console. And now the pay internet bill, this is the record that we created recently on 13th of May, right? So yeah, we can just change this value, pay mobile bill, and I will select mobile bill and I just save, and it will refresh and it will create one more record. So there are three records as of now, there will be four records. So you can see, I mean, we have just consumed the GraphQL API powered by AWS AppSync in Angular application, and since we are able to consume it, I am just printing it in console, but you can just assign those response in variables and just bind the entire data to the UI to display it. So I mean, this is how you can do it. And similarly, I mean, as in this demo I showed you how to do it with Angular, but similarly, the you can implement it in React or Flutter or any other client framework, and the documentation is available for various framework here. So you can just refer this documentation and the basic concept from this video to implement it in other front-end framework. So that's what I wanted to cover in this video, and I hope that this video would be useful for you. So you can like this video and subscribe my channel for more such content. Thank you very much for watching.